Now that we are well equipped with all the equation manipulation techniques, let's put them to use. So in section 1, number 1 here, we see that, I'll just write the question. So I see that x plus 6 is equal to 18. I want to solve for x. I want to get x to be by itself. I'm seeing I have this plus 6 here, which is preventing that. So I need to perform subtraction. I need to minus 6 from both sides. I then see that x is equal to 18 minus 6, which is 12. Moving on, we see that 5x is equal to 35. I want to solve for x. I want to get x by itself. So what's preventing that is this 5 that is being multiplied by the x. To cancel the multiplication, we need to perform division. We divide both sides by 5. We see x is then equal to 7. Next in line, we see that x minus 9 is equal to 4. We need to solve for x. We need to get x by itself. Therefore, we need to add 9 to both sides. So x would be 4 plus 9, which would be 13. Last of section 1, we see that x over 3 is equal to 7. We want to solve for x, but we have this 3 that divides x. To get rid of this divided number, we would multiply. So I multiply both sides by 3. The 3's cancel, and x is then equal to 21. Let's ramp up the intensity with section 2. The first question, number 5, says that 2x plus 5 is equal to 17. Same process, we need x isolated by itself. So I would first get rid of this 5. Now, we could have first divided by 2, but that would make the equation a bit more complicated. Let's do it so we would see why we need to minus 5 first. So if we were to divide the entire equation by 2 first, what we would have is 2x plus 5 is equal to 17. I divide both sides by 2. So I see then I would have x plus 5 over 2 is equal to 17 over 2. And while this could be solved, it's a bit more complicated. So what we would do instead of dividing by 2, we would minus 5 from both sides. So 2x would be 17 minus 5, that's 12. Now I would divide both sides by 2. So x would be 6. Next up, we see that 4x minus 7 is going to give 21. First, we would add 7 to both sides. So 4x is seen to be 28. We would then divide both sides by 4. We see that x is equal to 7. Next question says that 3 into x plus 4 is equal to 24. Now this question is a little bit different. Now we have to perform an intermediary step before we go ahead and solve. So we will multiply 3 by x, and then 3 by 4. We need to multiply everything on the outside of the bracket by what is on the inside of the bracket. That's how we expand this bracket. So we see that 3x plus 12 is equal to 24. I would then minus 12 from both sides, so 3x is equal to 12, and x would be equal to 4. Last on the list of section 2, we have 5x plus 6 equal 2x plus 18. Here we see we have x's on both sides of the equation. What we need to do is get all the x's on one side and all the numbers or the elements without x on one side. So we use the same equation manipulation techniques to achieve this. I would minus 2x from both sides. So I have 5x minus 2x plus 6 gives, and 2x minus 2x is 0. I would leave that out. I would rewrite the 18. Okay, I would now simplify the x's. As well, I would minus 6 from both sides. 5x minus 2x, that's 3x. 18 minus 6, that's 12. I would now solve for x by dividing both sides by 3. So x would then be 4. Clear the ramp, the intensity is about to go up. So section 3 here we see number 9 tells us that x squared is equal to 49. We need to solve for x. Here we have x squared. To cancel this x, what do? We take the root. So we take the square root of both sides. So we see the root and the square cancel, so x would then be 7. However, it's not just 7, it's going to be plus or minus 7. I'll give you a quick rundown why. If we were to take 7 and square it, we would get 49. If we were to take minus 7 and square it, we would also get 49. Right? So that's why when we take the square root of a number, it's always plus and minus whatever number. Right, so that's number 9. Next in line, we see that the square root of x plus 9 is equal to 7. We need to solve for x, and to do that, we would take the square of both sides. So both sides would be squared, because this square and this root will cancel. So we see that x plus 9 would give us 7 squared is 49. To solve for x, I would then minus 9 from both sides. X would be 40. Now the next question might seem a bit challenging, but I know you're up to meet the challenge. So let's go. We see that 2x plus 3 over 5 is equal to 9. We need to solve for x. Here the first thing I would do is multiply both sides by 5 to get rid of this divisor right here. And so both sides of the equation multiply by 5. Cancelling gives that 2x plus 3 is equal to 45. We solve as usual, we minus 3 from both sides, therefore 2x would be 45 minus 3 is 42. We then divide both sides by 2, so x would be 21. You made it to the end, give yourself a pat on the back. So last question on the list tells us that sine x is equal to 0.5. Now what do we do here? This sign you see here, this isn't a regular operation such as addition or multiplication. We can't divide both sides by sign, unfortunately. But there is something we could do. I'll explain what it is in a second. But first, this sign you see here, this is a function. What this is a graph. Right, so we can't eliminate this in the usual way. The way we do that is by taking something called the arc sign or the inverse sign on both sides. So if we were to take, and this is how it looks on the calculator, sine to the minus 1. If we were to take sine inverse of sine of 30, go ahead and calculate this and see what it gives you. And then try sine inverse of sine of 40 and see what that gives you. What you would see is that these cancel each other out and just the number remains. So to solve this, we would take the inverse sine of both sides. So we see then x is equal to the inverse sine of 0.5. This can be calculated on a calculator. Use a second function to access the inverse sine function. And when calculated, this would give us 30 degrees. There is another solution, but that isn't covered in the sponsor of this course. Here are now a few questions for you to try on your own and the answer key next to them. And if you're interested in online classes, go ahead and give me a call.